Okay, we've come here today to talk about the ElectroLock. The ElectroLock is an electronic door restrictor that uses several different methods to unlock the door, depending on the elevator conditions. The Model A uses RFID actuation. It also uses targets that are mounted in the hatchway. Now, this system is reliable for several reasons. The biggest single reason is it's not affected by dust, smoke, or debris in the hatchway. The RFID reader is a very forgiving system. It is designed to work with small credit card sized targets, which we call electro sensors. And those targets are used to unlock the door when targets are sensed by the radio frequency identification device. The second model is the B model. The B model works on door zone activation. What does that mean? It means the B model actually connects to the controller, and there are no targets to mount in the hatchway. So of the two models of the Electrodyne ElectroLock, the B model is the quicker model to install. How is it mounted on the door operator? Well, let's take a look at a couple of pictures. Here we have two pictures of a Dover door operator. If you'll notice here, the ElectroLock is mounted on the header and intersects the locking block when the door is fully closed. There's another angled picture of where it's mounted, and this gives you kind of an idea of the clearances that you have between the ElectroLock, its mounting, and the elevator car door hanger roller assembly. You'll notice there's not a lot of space here, but it's certainly enough that this can be mounted. Okay, let's talk about the ElectroLock components. The main component of the ElectroLock, the component that actually is the muscle of the system, is a component we call the Magna latch. The Magna latch itself contains a bistable solenoid, a micro switch, a car top manual release, and positive action switch. Let's look at those components one at a time. First of all, the bistable solenoid. The bistable solenoid is a stainless steel rod that runs on a brass sleeve. It's a bistable solenoid, therefore it'll maintain bolt position regardless of power. If the unit is in the lock position and power is lost, it'll stay in the lock position. If it's in the unlock position and power is lost, it'll stay in the unlock position. Interestingly enough, the bistable solenoid has a full 1-inch throw, which means it leaves you a lot of leeway when you're installing this. So your clearances aren't so tight that it needs readjustment from time to time. You've actually got a 1/2-inch clearance above and below the locking block, which we'll get into in a minute. The next component we find inside the Magna latch is the micro switch. The micro switch is used to monitor the bolt position. And because we can monitor the bolt position, we know when the bolt is in the lock position and unlock position. And consequently, once we reach one of those positions, we can shut power off to the solenoid. This elongates the solenoid life to a great degree because it's not powered continuously. It's only powered long enough to move it into either the locked or unlocked position. Again, monitored by the micro switch, which is mounted in the overall Magna latch box. The next thing we find is the positive action switch. Positive action switch is an optional feature. It's mounted to the top of the solenoid, and if you'll notice, there are 4 contacts mounted to, actually it's mounted to the bolt itself. So it moves up and down with the bolt. At least the conduction portion of it does here. And if you'll notice around the bottom, there are 4 contacts. Those 4 contacts are mounted on top of the solenoid. So by utilizing this method, we can tell for sure if the bolt is in the locked or unlocked position and feed that back directly to the controller. This is a true positive action switch in that the switch can't be made until some positive action, until the bolt is in the lock position. That gives us positive feedback of bolt position in addition to what we get from the micro switch. It provides lock confirmation to the controller. What does that mean? It means that it tells the controller that the door is secure. Also built into the Magna latch is the car top manual release. The manual release unlocks the car in case power is lost, and the mechanic chooses to release the passengers. He can reach up, put his finger through the ring, pull it up, and it lifts the bolt into the unlocked position. It's easier for a mechanic to unlock the door this way, thus making it the ideal method for unlocking. ElectroLock components. Okay, let's take a look at this. This is the controller interface, the brain of the system. The brain of the system monitors bolt position and applies power to the bolt whenever we want it to move, either locked or unlocked. It is supplied in a sturdy aluminum cabinet, and any power source can be used to power up the ElectroLock. All other electronic restrictors require 120 volts AC, which can, from time to time, depending on the elevator system, prove to be a problem. Not all elevator systems have 120 volts AC on their car top. Our unit will work on any voltage it encounters on the car top, not necessarily that specific 120 volts AC. It'll work on 100 volts DC, 250 DC, 220 AC, whatever controller voltage is located on the car top. This saves the installer from having to run special wire from the machine room to the car top, which is a tremendous time saver on installation. Okay, if the A unit is used, then we have provided in the ElectroLock 2 signals to assist the installer in aligning his targets. The first signal is an audible signal, which will give him an audible report when he has a target lined up with the RFID reader. And of course the second signal is a visual signal, which is represented by a 1/2-inch LED, red LED, inside the box, which will basically light up the whole box. So you really have 2 signals. He can do it just by listening, picking up the audible tone, or by looking in the box for the red LED, so he knows that he has now engaged the RFID reader, and then he can lock his target down accordingly. The A model uses targets and RFID activation. It's ideal for up to 8 landings or less. The reason I say that is because once you get above 8 landings, mounting targets becomes a tedious process, even for us. There's a labor factor involved here. We suggest don't go above 8 landings if you're going to go with the targets. And of course it always depends on the type of controller, and I'll explain that in a moment. Controllers ideal for the A model would be Beckett, Dover Composite, Elevator Systems, ESI, Relay Logic, GAL, Horn, Montgomery Micron, Otis older controllers, Shepherd Warner, TAC 32s, TXR5, and Westinghouse. Model B differs from Model A in that it doesn't require targets for activation. Model B works directly from a door zone signal. It's ideal for 8 or more landings and high-rise buildings. And of course, this again depends on the controller type. But in most cases, what you'll find is there will be an available door zone signal on the car top that the installer can access to trigger the system when he gets into the unlocking zone. These are just a few of the controllers that the B model would be appropriate to use with. ACCT, Armor, Century, Murphy, Northern, O-Thompson, a lot of the old Otis 211s, 311s, 411s, LRSs, MRSs, Otis Universal, GCS. All of these controllers produce a door zone signal that we can use to unlock the door. thus removing the need for targets in the hatchway and saving a whole lot of install time. Door restrictor comparisons. Let's talk about the comparison between mechanical and electronic door restrictors. We mentioned earlier there are two types of restrictors. We've been talking primarily about electronic restrictors, specifically the ElectroLock. Let's talk a little bit about a comparison between these and mechanical restrictors. When is a mechanical restrictor ideal? A mechanical restrictor is ideal in very short rises, no more than 3 or 4 floors, for a lot of reasons. The biggest single reason is trying to keep a mechanical restrictor aligned and keeping the parts from wearing out. That's the big issue with mechanical restrictors. The alignment process is very time consuming, and once it's aligned, it has to maintain that alignment ongoing for the life of the elevator. Well, that's really kind of tough because that alignment is subject to a lot of variables. The biggest single variable is the car steadying plates, which keep the cab in relation to the hallway in the same plane all the time. If those steadying plates start to wear or become loose, obviously the whole cab is going to shift, and that's going to change the alignment between the mechanical restrictor and the outside holder. And in some cases, you can actually rip everything out if the car should sag forward far enough. Another problem with mechanical restriction and alignment is the roller guides or slide guides that the elevator itself runs on. Again, they wear, they get out of alignment, they get out of adjustment. That causes the elevator travel to change and the clearances to change. And once that happens, your mechanical restrictor can become distressed. It can either miss the door completely or start ripping out the door locks. So in both cases, alignment is a serious issue. It has to be addressed and has to be maintained via maintenance, which makes them pretty much maintenance intense if you're going to keep the system working correctly.